All right, let's take a look at section 8.2, analyzing arithmetic sequences and series. Some people like to say arithmetic, some people like to say arithmetic. Potato, potato, right? I'll probably say arithmetic, maybe I'll say arithmetic. I might switch back and forth. I get confused as well on this. So let's go ahead and get things rolling. We're going to split this up into 2 days. The second day uh, won't be as long. The first day is going to be a lot longer. So let's take a look at a few terms right here with the arithmetic sequence. What is it? It is when the difference of consecutive terms are constant. If we think about what happened in 8.1, maybe we're trying to look at for patterns. And so one of the patterns that I really wanted you guys to hopefully find, or was that it may be from one term to the next, because you were given a list of terms. It would be like 2, 4, 6, 8. The differences were constant. Okay, if I gave you 2, 4, 6, 8, the differences would be plus 2, plus 2, plus 2 each and every time. So that leads us to this next term that we have, which is the common difference. And we use the variable d right here to represent common difference. And the common difference is the constant differences or difference between the terms. In my example of 2, 4, 6, 8, the common difference would be positive 2 because it's going up 2 each and every time. If it was like 8, 6, 4, 2, then my common difference would be negative 2 in that instance because it is subtracting 2 each and every time. All right. So next, we take a look at the arithmetic series. Now, what is that? That is the sum of the finite series. Remember, a finite series is a series where there is an end, right? It could be 100 numbers. It could be as small as 3 numbers in the in a finite series. But you're going to add all the different terms together. All right, and that is the arithmetic series, which we'll take a look more so come part B. So there are some rules that you got to know. The rule for the arithmetic sequence, okay? There's pretty much this equation right here that you need to get yourself very familiar with, okay? And in this um, sequence right here, or equation, we have a sub n. Remember, the nth term, whatever it might be. It could be the 100th term, the first term, well, not the first term, but second, third, fourth, fifth, whatever term it could be. It's notated by a sub 1, which is the first term. And then we have n, which represents whatever term we're dealing with. It could, once again, be the 50th term, the 7th term, the 100th term. And then you have d, which is your common difference. So make sure this right here, you memorize, all right? So if we take a look at the problem or the example that's given to us, in the arithmetic sequence, the first term of 3, okay, so that would represent a sub 1. And so right here, a sub 1 is 3. It's substituted in there. Plus parentheses n minus 1. And then you have 2, which is represented by your common difference. So we have the common difference right here, and it's substituted in where 2 is. And then so once you have your equation, you start off, you plug things in, and then after the words, let's go ahead. We're going to distribute the 2, and we're going to simplify this out. You don't want to just leave it as is. You've got to simplify the question or the equation. And then this 3 plus 2n minus 2, that simplifies to your answer right here, which is 2n plus 1. And so we always want to put the term with the variable first. It's like just common practice, one of those things that You do because it's the right thing. All right. So it's 2n plus 1. We call it like best practices. All right. And then there you have your arithmetic sequence. Next up, let's go ahead and move down to the sum of a finite arithmetic series. Now we'll take a look at this more in part B. So how about we'll save it for then. Let's go ahead and move on to our extra practice right here. We'll take a look at number 1. Okay. So first off, we're supposed to tell whether the sequence is arithmetic and then explain your reasoning. Okay, so remember, we need to find, is there a common difference? Okay, so that's kind of the main thing. Find the CD, meaning common difference. And so let's take a look at the terms right here. All right, we got from 1 to 4, that's plus 3. From 4 to 7, that's plus 3. 7 to 12, that's plus 5. And then we have plus 5. Now, it has to be a consistent common difference from beginning to end. Yes, we could say that there might be a pattern right here. Hey, the first 2 terms is plus 3, the second 2 terms is plus 5. We might be able to safely say that the next 2 terms after that is going to be plus 7. But that, we're not looking for that type of a pattern. We are looking for common differences. So right here, we can go ahead and say this is not arithmetic or arithmetic. I don't know, it sounds better when it's arithmetic, I feel. Not arithmetic. It just seems a little off. So, and then we have to explain our reasons, and then simply put the differences are not constant. Okay, and there you go. That's it. Let's take a look at number 2. Okay, so let's take a look at from like the first term to the second term. That's -3. Second term to the third, -3. So it looks like it's subtracting 3 each time. So we can go ahead and say that this is arithmetic. And why? Well, we have a common difference of -3. Okay? And I'll go ahead and accept that as an answer right here. Hopefully that's pretty straightforward, right? So let's see what other scenarios we have. On number 3, hopefully we could figure out, hey, we got plus 0.2. The second and third term is plus 0.2. And you want to make sure you check all of them, because you never know if they try to trick you right here at the end, like they did, like on number 1. Well, not necessarily at the end, but they do try to fool you. And right here, I do see that there is a common difference. So we can go ahead and say that this is arithmetic. And then we have D, our common difference is equal to 0.2. All right. Let's take a look next up at number 4. We got 1/2, 1/4, 1/6, 1/8, 1/10. This looks pretty interesting because I think they're trying to trick you. From 1/2 to 1/4, is that adding 1/2? Don't think so, right? If I take 1/2 and I add 1/2 to that, that equals 1. Now, if I take 1/2 and then right here possibly multiplied by 1/2, then I get 1/4. And if I take 1/4 times 1/2, well, I don't get 1/6. So that's not even it either. It looks like they do a very good job of trying to trick you right here. And maybe you fell into that trap. Let's hope you won't. So this right here, we can go ahead and say is not arithmetic. No common differences. Although it may look like it because you're saying, hey, what do I just add 1/2, 1/2? But remember, you got to have common denominators to add things together. And that's the trick right here. Okay? All right. Next up, It says write the rule for the nth term of the sequence, and then we have to find a sub 20, which is the 20th term right here. All right, so I think first and foremost, we got to know what the equation is. And it's a sub n is equal to a sub 1 plus, we have ourselves n minus 1 times d, which is your common difference. So now that we have that, okay, let's take a look at some of the key things right here. I'm highlighting that 3 because that's a sub 1. That's your first term. Right, so let me go ahead right here for this first one. We got a sub 1 is 3. And then we have to figure out, well, is there a common difference? From 3 to 9, that's plus 6. From 9 to 15, that's plus 6. 15 to 21, that's another plus 6. So what it looks like right here, we have a common difference of positive 6. So now, let's go ahead, let's start plugging things in. All right, a sub n is equal to a1, which we said is 3. Then we have plus, and then we've got n minus 1 times our common difference of 6. Okay? And so we go ahead and simplify things out. an is equal to 3. We're going to distribute the 6, so we got 6n minus 6. And then remember, let's go ahead and put the variable up front, and then 3 minus 6 is going to be negative 3. So there, that right there is the rule. Okay? You got to know the rules, and that right there is it. The last thing they do ask is to find the 20th term. So when I plug in now a sub 20, and then remember, n would be 20 here, and we plug that in and get our answer. So 6 times 20, we end up with 120 minus 3, that's 117. So we've got 2 parts to our answer. One is the rule. The other is what is the 20th term, which we just solved for right now. All right. So hopefully that looks good. Let's take a look next at number 6. Okay, so we've got our set of numbers. And first off, let's determine what the first term is. And hopefully we realize, hey, a sub 1 is 8. Then after that, we figure out what is our common difference. And I look at from 8 to 3, that's minus 5. 3 to negative 2 is minus 5. And negative 2 to negative 7 is minus 5. So I can safely say right here that my common difference is negative 5. So now it's just a matter of let's plug things into our equation. We start with a sub n. And remember, that equals a1. So I'll plug in 8. And then we have plus n minus 1 times our common difference, which is 5, or negative 5 in this instance. Okay, so now that I have this, we will go ahead and distribute and simplify. And so we got 8 plus, and then let's go ahead and put negative 5 and then we have positive 5. We'll go ahead and simplify it all together, and a sub n is equal to negative 5n plus 13. All right. Don't forget the last step. They ask for you to figure out what is the 20th term. And the 20th term, a sub 20, we got negative 5 times 20 plus 13. So we got negative 100 plus 13, and that right there is going to be equal to negative 87. Okay, so once again, we got 2 parts to our answer. One is finding the nth term, the rule, and then the next one is finding the 20th term. All right, so we pretty much, as long as you know that equation, you'll be in good shape right here. Next up, let's go to number 9. It says, write the rule for the nth term of the sequence where a sub 12 is equal to negative 13 and d is equal to negative 2. All right, then graph the first 6 terms of the sequence. All right, so in order for me to write the nth term or the rule, remember the equation is a sub n is equal to a1 plus n minus 1 times your common difference. But if you look at the problem, they don't give me the first term. They give me the 12th term right here. So we have to be able, hopefully they gave us enough information to solve for the first term. And they actually did, fortunately. And let's go ahead and plug things into this equation right here. But we start with what's the 12th term. So let's go ahead. I'm going to plug in a sub 12. Okay? And a sub 12 is actually a number that they gave us. So I'm going to go ahead and plug in negative 13. A1 is unknown. And what do I plug in for n? Well, remember, which term is this? This negative 13 is the 12th term. So I'm going to go ahead and plug in 12 right here for n. And then put minus 1. And then we plug in the common difference, which is negative 2. And so now, all you need to do is go ahead and simplify the equation out. And then guess what? We can solve for a sub 1 coming right up. Now, negative 13 is equal to a sub 1 plus, we got 12 minus 1 is 11 times negative 2. And then 11 times negative 2, that'll go ahead and get us negative 22. And then we can go ahead and simply add 22 to both sides. And a sub 1, which is our first term, that is going to be equal to 9. All right. So a sub 1 is 9. Super duper. And so what we could do now is take that and plug it into the original equation because they gave us the common difference right here at the top. Whoops. And now we have a sub 1. So let's put the rule together right here. And the rule is a sub n is equal to 9, which is a1, plus n minus 1 in parentheses times negative 2. We'll go ahead afterwards, simplify this out. Negative 2n, and then we've got our subs plus 2. And let's go ahead and rewrite this. A sub n is going to be equal to negative 2n plus 11. And we'll put that into the correct format right here, and we have our rule. All right. So use what they give you. And the only equation you really need to worry about right now is the arithmetic sequence. All right, or the series, and then, or sorry, sequence. And then you can go ahead and find your nth term equation. The last thing right here they do ask is to graph things out. So I can do that right here. If we go ahead and put our axes together, we have a sub 1. So technically this is 1. And up here we have ourselves 9. Right? And at that rate, as we go through each and every number, remember it's common difference of negative 2. So at 2 right here, it's going down 2. So there's that 7. And then 5, 3, And then actually the sixth term, it ends up going in the negative direction, and it's right there. I'll put it inside the circle of the 6. All right, and there you go. We now have our graph. All right. We'll take a look at one last question right here. Look at number 10. We've got to write the rule for the nth term of the sequence. Except this time, they don't give you a sub 1. They don't even give you the common difference. So what am I supposed to do right here? Well, that's what I want to show you. You are going to have to pretty much do what we did in number 9. You're going to have to do it twice, and you have 2 equations, 2 unknowns. All right. So let's see how let's put this all together. Let's start with a sub 8. Okay, that is 59. So I'm going to put right here 59 is equal to a1. Okay, and then we got ourselves plus 8 minus 1 times d. All right, there's one of our equations. I'm going to next do the same thing with a sub 13. And I want to plug in 99 because that's the 13th term, and that's equal to a sub 1 plus 13 minus 1 times our common difference. Now that we have that, let's go ahead and do a little reorganizing and reshuffling. Okay, let's simplify things out a little bit. And so we have 59 is equal to a sub 1, and then this becomes 8 minus 1 is 7, so we got plus 7d. All right, with the 99, let's do the same thing. So I got 99 problems. And then we got right here, I won't say the rest, and we got ourselves plus 12d. I guess 99 problems, but this math problem ain't one. All right, so we got this right here. And what do? I've got 2 equations, 2 unknowns. Hey, maybe I could set things up somehow to solve this out. All right, and lo and behold, I can. What I'm going to do is this. I'm going to take this 99 equal to a1 plus 12d. I'm going to put that on top, and I'm going to take the other equation, 59, and put that down below right here. And guess what I'm going to do? Guess what I'm going to try and do? We've got several things that we've learned so far in this school year, and even in Algebra 1. I'm going to go ahead and use the addition method to try and get one of the equations or one of the variables gone. And one of the variables I can get going is that a sub 1. But in order for me to add the 2 together, I am going to have to take the bottom equation and change everything to -1, or multiply by -1. Because I need to add things together, and by doing that, that'll change my signs right here. Now we'll go ahead and use the addition method. And so 99 plus 59, right, or here, let me rewrite this. We got ourselves -59 is equal to -a sub 1 minus 7d. Don't know what's going on right there. I tried to do a little shortcut, but it didn't work. Hold on one second. Let me go ahead and just write it down over here. And so by using the addition method, a sub 1 disappears, and I could find my common difference at least. All right, so now that let's go ahead and do that. 99 plus negative 59, that ends up getting me right here 40, and that's equal to 5d. So let's get d by itself, and d is equal to 8. Okay, so I have d. Hey, we're getting closer to putting our rule together. So what else can I do next? Well, I still need to find a sub 1. So what I could simply do is take this d and plug it into one of the two equations that I have up top, either the 59 or the 99. And so right here, I'll plug it into the 59. Hey, numbers are smaller. So we got 59 is equal to a sub 1 plus 7 times, and I'm going to substitute in right there, an 8. And then we go ahead and solve things out. We got 59 is equal to a1 plus 7 times 8 right there. That happens to be 56. And so when I subtract 56 to both sides, the first term is 3. The common difference is 8. So we got one last thing to do. Let's take both of that and let's come up with our rule. So a sub n is equal to, we have right here, what do we do? We got a1, which is 3, and then plus n minus 1 times 8. We're going to go ahead and distribute things out. And then let's simplify it all together. We'll put the 8n up front, and then 3 minus 8, that becomes negative 5. And there is the rule for the nth term. Okay, it does take a little bit of time. Just kind of go through the steps that I've shared with you right here, and I'm pretty sure you'll be able to get this answer as well. Okay, that's why we're going to take 2 days on it, because stuff like this is a little complicated, or I guess more just time consuming, but it's nothing that's out of the scope of what you guys are able to do. All right, and there you go, the first part of 8.2.